Hello everyone and happy Friday. Today we're looking at rotations on the coordinate plane. So we're looking at rotations right here. It says a rotation blank, so a rotation turns a figure around a fixed point called the center of rotation. For our examples, the center of rotation will be the origin and will rotate in increments of 90 degrees. Alright, so a couple important things here to remember. To pay attention to the direction of the rotation. So are we going clockwise? So think about a clock. You'd have 12 here and the clock moves to 1, 2, 3, 4, 5, 6 and so on. Moving clockwise is going in this direction right here. Or are we moving counterclockwise, meaning we're going in the opposite direction, like we're moving left, or this one we're kind of going in a right, right? And then consider each quadrant as another 90 degree in the rotation. So if we start here and we're rotating clockwise, my first rotation will be 90 degrees, another rotation would be 180, and another rotation would be 270. So right here, starting point is always 0. No change, 0, starting point. Make a rotation, add 90. Make another rotation, add another 90 to give me 180. Make another rotation, add 90 to that, it gives me 270. Alright, so find the number of degrees in each rotation shown below. So here we go, we have a pentagon here with A. Remember, this does not have the apostrophe, so this is the image I'm going to start with. You always want to start with the figure with the letter in it that does not have the apostrophe. That's your pre-image. No apostrophe, it's pre-image. So we can take this pentagon and we're going to rotate it one time that way. So as you can see, it turned. We did one turn that way. So that would be a 90-degree turn. Now, thinking about it another way, if I did a rotation going counterclockwise, I would have done a 90, a 180, and then a 270 to get there. Okay. So here's what they're asking. If I rotated clockwise, how many degrees did I rotate it? Well, I rotated it 90 degrees. Or if I rotated the figure counterclockwise to get to that figure, how many degrees did I rotate it? 270 degrees. Alright? Let's take a look at number 2 here. Here's my original figure. So, if I'm rotating this clockwise, I'm moving 1, 2, 3 quadrants. So it's 90, 180, or 270, right? So since I went clockwise, I went 270 degrees to get to my image. If I look at my pre-image here, and I move counterclockwise, I'm only going to go one rotation, so that is only 90 degrees. Okay, so remember, if you're going to start with a figure, you start with the one that does not have the apostrophe. Clockwise means we're going right. So I want to know how I rotated it over to here. So I rotated it 90, 180. Clockwise. And then, as well, I rotated from here, 90 to 180. So it looks like when they're on opposite sides of each other, like this, that's going to be 180 for both. That's pretty cool. Alright, let's scroll on down. Now you're going to do these, just like we did on the top. So if you need a review on how we did those, just go back in the video and check that out. Alright, number 7 here. It says, rotate the figure shown on the right 90 degrees. Then you're going to rotate it 180 degrees. And then and then 270 degrees clockwise. So we're always rotating clockwise. After each rotation, record the coordinates of the image in the appropriate table. So what they did for us is they put it here already, and those coordinates are going to be listed right here. And I already know those are the right answers, right? A is 2 and 1. These are the coordinates for this triangle right here. So then it says rotate it to the right 90 degrees. So when you're done rotating this figure 90 degrees, you got to put the coordinates there. So you're going to need to rotate it 90 degrees clockwise. So we're going to be moving this figure around this way. All right, let's see if I can help you out with that. Make a little figure here maybe. I'm going to rotate it that way first. And then once you're done with that one, you're going to rotate it this way next. So you take the figure and you're going to rotate it that way. And then the same thing on the other one. So that's the way we're going to be rotating it. Clockwise. Alright? When you're rotating the image, you're going to have something. I put up a website here. It kind of helps. So here's a similar object, and I'm going to rotate it 90 degrees. So I'm going to take my figure, I'm going to start rotating it 90 degrees. And watch how it doesn't exactly reflect, but we're going to have a whole new set of coordinates. Okay, now some of these coordinates I can tell will be the same. So for example, in this coordinate, I have the same one as this one right here. If I want to go ahead and do another rotation, it's going to look like this. And then when I rotate it again, finally it's going to end up just like that. If I did a whole 360, it would become full circle and end up right back there. So again, I rotate it 90. Then I rotate it again, 180 degrees. And again, 270 degrees total. So that's going to be your process for rotating those. Once you've rotated it, you can write your new coordinates here. So once you rotate it 90, you can write those coordinates here. So once you rotate it 90 degrees, right? These are your coordinates that are right here. Your first image. Your first image is already there for you. Then when you're done, you got to rotate it 90 degrees. So you're going to have a whole new set of coordinates after you're done rotating it. So after you're done rotating it into this first rotation, you got to plot your new coordinates for A there, B there, and C there. Then, once it's there, you got to rotate it there. When you're done rotating it there, you're going to see where the vertices line up when they plot those right here, right? The new coordinates there. It says, look for patterns and try to create the algebraic representation for each rotation. So I just put some guided questions here. So what are the coordinates? What are your original coordinates for point A? So your original coordinates for point A are 2 and 1. All right? 2 on the X, 1 on the Y. So then it says, what were your new coordinates for point A after rotating 90 degrees? So after you've rotated this 90 degrees, you want to write those new coordinates right there. So you're going to have something very similar here after your rotation. And I'm going to go ahead and fill these in for you. So after you rotate it 90 degrees, your point A is going to be 1 and -2. And when you rotate it again, your new one is going to be -2 and -1. And when you rotate it the third time, it's going to be -1 and 2. Okay, so what patterns do you see when you put all of these all these ordered pairs together? So look, I had a positive and a positive and a negative and a negative, and then a negative and a positive. Okay? And do they switch? So we had our original image was for point A was x is 2 and y is 1. When I rotated it, I got 1 and -2. And then when I rotated it again, I got -2. I'm sorry, this should be a -1. And then when I rotate it again, I got a -1 and a -2. So we do see a little bit of a pattern here, all right? And what is happening to those patterns, right? Also, you can remember that your quadrants have certain values for your x and your y. So, for example, in one quadrant, your quadrant 1, your x is positive and your y is positive. And then your quadrant 1. In quadrant 2, x is positive and y is negative. So any ordered pairs down here, you're going to have a positive x and a negative y, right? Positive x right here, negative y. All your ordered pairs will be like that. Down here, you have a negative x and a negative y. Down here in quadrant 3, all your ordered pairs are going to be negative and a negative. So when you rotated it the first time, your ordered pairs were a positive and then a negative. When you rotated it the other time, you ended up in this quadrant right here and you had a negative and a negative. And when you rotate it up there, your x is going to be negative and your y is going to be positive. So your x is negative and your y is positive. So again, look for the patterns and try to create an algebraic representation for each rotation. I mean, right here, the ones I just did are algebraic representations. So you might want to help. That might help you with your answers for down here. Algebraic representations after each rotation. And you can describe what happened in your own words. And it says, use the coordinates below to represent rotations. Use what you've learned today to describe what type of rotation occurred. So they want to know what's happening to these points. So you had your original here was 9 and 8, and then they rotated it 8 to -9. So what type of rotation was that? I mean, let's take a look. We had a positive, and then we had a positive and a negative. So here we had a positive and a positive, and then a positive and a negative. Looks like that was a 90-degree rotation. Now if that's a 90-degree rotation clockwise, that means we also have a counterclockwise rotation of 270 degrees, because you can go the other way too. So all I did was I compared these points to the points kind of up here in the example. So I had a positive and a positive, and then a positive and a negative. So I had a positive and a positive, and a positive and a negative. So I knew that going clockwise would be 90 degrees. And then on the other hand, it could also be 270 degrees, because if I went clockwise, I went 90. But if I had to go the completely other way, I would have gone 90, 100, 180, 270. Alright? And it says, do your rotations preserve or change the orientation of the figure? Right? So it's asking if the shape stays the same. I mean, is the triangle always pointing up? And so if it's not always pointing up, that means it changes. And then number 12 says, do rotations preserve the orientation of the vertices? All right. So you can go ahead and write whatever you would like there. All right. That's going to be today's lesson. Have a great Friday, everybody, and be safe.